Okay, let us calculate moment of inertia of this disk. Okay, you can see this disk about this axis. Okay, this axis is you can clearly see is a tangent. Okay, and in tangent in its plane, it is not perpendicular, it is not perpendicular, it is in its plane. Okay, so you can clearly see this disk is in xy plane, and this is, you can say, this line is parallel to y axis. It means this line is a tangent in its plane, not perpendicular to its plane, not z-axis, not z-axis passing through this point. It is parallel to y-axis, means tangent in its plane. So about this axis, how to calculate the moment of inertia of this disk, whose mass is m and radius is capital R. Let us see. We'll use perpendicular axis theorem as well as parallel axis theorem to find the moment of inertia of this disk about this axis. Okay, if it was, see, if tangent was perpendicular to its plane, we could have used directly parallel axis theorem. About this, you know, it is about center of mass perpendicular to its plane, moment of inertia of disk is mr square by 2. Using parallel axis theorem, you could have easily find moment of inertia about a tangent perpendicular to its plane. Okay, you could easily find, but here this axis is parallel, means this axis is a tangent in its plane, so it is parallel to this axis is parallel to y axis, means it lies on the xy plane. This line, this axis of rotation, it lies on the xy plane, so it is in its plane, that is in the plane of disk. So here we have to use both perpendicular axis as well as parallel axis theorem. Now let us see. You can imagine disk is rotating about this axis. Okay, now see here, you can draw two diameter. One, using perpendicular axis theorem, what you can do, see, if z-axis is passing through this point perpendicular to this disk, then what you can do, if this is your x and this is your y, what you can do, moment of inertia about x-axis plus moment of inertia about y-axis is equal to moment of inertia which is passing through this center. Okay, that is perpendicular to its plane, passing through the center of mass perpendicular to its plane, that is, I can write z-axis. Okay, z-axis. So here this case, about x-axis and about y-axis both are diameter, and condition is, you can see it is symmetric, either y-axis about y-axis or x-axis, moment of inertia will be same. So you can replace this by 2ix, because ix is equal to iy is equal to iz. Moment of inertia about z-axis is, for a disk, it is mr square by 2, where z-axis is passing through center of mass and perpendicular to the plane of this disk. So clearly you can see moment of inertia about x-axis, it is equal to mr square by 4. So about diameter, it is mr square by 4 for a disk. This we have used perpendicular axis theorem. Okay, perpendicular axis theorem. This is perpendicular axis theorem. So here we have used perpendicular axis theorem. Now we will use parallel axis theorem in order to find our answer, that is for this axis of rotation. Now see here, I'll use parallel axis theorem. One thing you should remember here, this perpendicular axis theorem can be used only for 2D body. This is only for 2D body. Okay, this is only for this perpendicular axis theorem. I'll write here. Many students, they miss this concept. I'm writing here, that is perpendicular axis theorem. Perpendicular axis theorem is only for perpendicular axis theorem is only for 2D body, two dimensional, like disk or ring, you can say 2D body. Okay, only for 2D body. This is one point you should remember, and one more point, that is parallel axis theorem. parallel axis theorem can be used for any body, 2D or 3D. Parallel axis theorem, any body, means 2D or 3D. 2D or 3D, any body you can use parallel axis theorem. Now here in this case we have used perpendicular axis theorem. Now let us use parallel axis theorem in order to find moment of inertia about this axis. You see, you can clearly see this line, which is y-axis, means diameter, and this our main motto is to find about this axis. These two lines are parallel to each other. So clearly ix is equal to iy, so you can write here iy is equal to, this is also equal to iy, this is also equal to iy, moment of inertia about y-axis. Now since this iy, or you can say this line, this diameter and this axis is parallel, and the distance between these two axes is r, capital R, that is radius of this disc, so you can use parallel axis theorem. So now using parallel axis theorem, you can write moment of inertia about given, that is y-axis is equal to uh, moment of inertia about this axis, this is your y-axis, moment of inertia about this diameter plus total mass of the disk and distance between, perpendicular distance between these two parallel line, that is r, so mr square, so square of the perpendicular distance between these two lines. So iy is equal to, that is mr square by 4 plus mr square. So therefore about given tangent in its plane, that is 4 plus 1, that is 5 mr square by 4. This is your answer. So here we have used both parallel axis theorem as well as perpendicular axis theorem in order to find the moment of inertia of a tangent about an axis passing through a tangent in its plane. Okay, for this disk, means about this axis we have found moment of inertia. So always remember this perpendicular axis theorem can be used only for 2D body, but parallel axis theorem can be used for 2D as well as 3D body. If you have any doubt in perpendicular axis theorem and parallel axis theorem, you can comment. I can make video for both perpendicular and parallel axis theorem, or you can follow NCERT or any book, their derivation is given. Okay, so this concept is important, you have to remember this two star mark. Okay, thank you.
Don't forget to like, comment and subscribe PK Dye Physics for more videos.